Hello everyone, welcome to the next lecture on my non-parametric testing. Today we will discuss about the paired sign t-test. Myself Dr. Gar. You can simply follow my YouTube channel Dr. Harish Gar, where you can find the various lecture on this non-parametric testing. So what is the sign test is? This is one of the simplest non-parametric tests which are totally dependent upon their signs of their observation. What is the meaning is, if you have the observation x is say 4, -5, 7, 11, -121 and so on, then the testing of the hypothesis based on this sign test is not dependent on the values of the 4, 5, 7. Rather it depending on the values, because 4 is my positive, this is negative, this is positive, this is positive, this is negative. That's why this test is called as the sign test. This is based on the sign of the deviations but not on the exact numbers. This test is always applicable when you are talking about the median of the distribution. Remember, whenever you have to apply the testing of the hypothesis on the mean, then either you can apply the Z test or you can apply the T test, depending upon that whether you have the large sample or you have the small sample. Similarly, when you are talking about the variance, then you have to apply the F test. And whenever you are talking about the frequency on the testing of the hypothesis, then you have to apply the chi-square testing of the hypothesis. However, if you are talking about the testing of the hypothesis on the median, then you always look about the non-parametric testing of hypothesis, and one of the non-parametric testing of hypothesis is the sign test. What is the median is? So we all know that median is the position which divides a series into the two equal parts, or you can say the probability will be 0.5. So based on this sign test, we will look about the paired sample t-test. Paired is also called as the dependent sample sign test. It means if you have the two observations x and y, if they are dependent on each other, then we will apply the paired sample test. Now since we are working on the median, and we all know that if your distribution is my normal, then the mean and the median are always be the same. We all know that median, mode and mean all are same for the normal distribution. So it means whenever you are talking about the median and your testing of hypothesis is normal, then the sign test could be used to test the hypothesis for the mean of the normal distribution. But we all know that the mean of the normal distribution also can be used with the help of the t-test. So it means this test is same problem for the here. But the difference between them here is the t-test is applicable only for the normal distribution assumption. However, the sign test is appropriate for any distribution function, whether the distribution follows the binomial, whether the distribution follows the Poisson distribution, whether it's a uniform distribution, any of the distributions are there. So since it doesn't depend on the distribution function, that's why this is called as the non-parametric testing. Remember, what is the non-parametric testing is? That is when it does not depend on the distribution function. Any testing of the hypothesis which are not depending on the distribution function called as the non-parametric testing. So suppose you have the testing of the hypothesis H0 and H1 is one of them. This is called as the left tail, or called as the one tail test. This is also called as the one tail test. This is not equal to, we call as the two tail test. So once you have defined the testing of the hypothesis, then under this H0, what is the meaning of that? It means, what is the meaning of that when your H0 is 2? It means the number of the positive signs and the number of the negative signs are approximately equal. But what will happen if the differences are not same? If the differences in the positive and the negative signs is changed due to the variations or the fluctuations, then we fail to reject it the 0. So once you are now, we have to, based on this observation, we have to see when the sign test will be applicable on the pair test. Suppose you have the two different observations x and y. So these are these are the certain observation. Remember, if I consider this as my n1 number of the elements, this is my n2 number of the elements. In order to apply for the pair test, n1 is n2 must be there. Remember, n1 is n2 must be there. Whenever n1 is not equal to n2, then that test can never be the pair test. that is always be the independent sign test, independent t test, independent z test, or any are there. But whenever it should be the pair test, it must be n1 is n2, but converse need not be true. Where that is, whenever n1 is n1 and n2 both are same, it doesn't mean that it is a pair test. So you have to look firstly whether it's a pair or not. What is the meaning of the pair? If you have the two observations x and y, say 4, 7, 9, 1 and 11. If I consider y as say 5, this is 3, this is say 9, this is 4 and this is say 14. Then you have to compute the difference. Difference is x minus y, or you can consider y minus x. That's depending upon you. So what are the answer is? It is minus 1. If I consider here, this is my plus 4, this is 0, this is my minus 3, this is my minus 3. So some numbers are positive, some numbers are negative. How many positive numbers are there? There is only one. There is only one positive number. How many negative numbers are there? There are the 3 negative numbers are there, 1, 2 and 3. So based on this positive and negative, we define this as t positive, number of the positive signs. In this case, what is my t positive is 1. T negative, number of the negative signs. So if you look about that, what is the t negative is? That is my 3. This is the way you can compute the t positive, t negative. And n is my t positive and here. Depending upon this n, whether it's n is my large or small, we can define this here. Our target is to check whether these two median of the x, median of the y are same, or you can say eta 1 minus eta 2 is 0. That means the difference of the median are 0 or not. That is, the median difference is my 0 or not. So this can be done with the help of the observations. So based on this nature of the n, whether this n is my small or large, whenever n is my greater than or equal to 10, we call it as the large sample. Whenever n is less than of the 10, we will call as the small sample. Remember, for the parametric test, we always consider this as my large sample, but for the non-parametric, this is the case for the sign test. So firstly, look at the small sample. We will consider the 3 testing procedure. We will define the testing of hypothesis based on the nature of your H0 and H1. It could be here, or it could be here, or it could be here. These both cases are called as the one tail, and this is my two tail. Once you define this H0 and H1, we will compute the t statistics. That is, based on these two observations x and y, we compute the t positive and t negative as I explained earlier. Then we can compute the value of the n, that's the sum of them, and t as a minimum of this. Depending upon this value of the n, we will define the large or small. Now once you are defining the n, we will see the critical value of this x, add this value n for this level of significance, whether it's a one tail or the two tail. How do you find that? You can take from this critical value table. Once you are defining this, for example, if say what is the value of the TC at 5% level of significance with 7n. So 7 is not be there, so minimum value is 9. So say 9 level of significance is for the one tail here, for the two tail is this one. And based on this value of the TC, we can define the critical region. Now check whether the computed value of this T from the step number 2 is lies in here. That means this is my rejected H0. Otherwise we will accept it. So look at that. We will explain the 3 examples. Firstly for the small sample. Later on we will discuss the large sample. Now first question is, you have to check whether it's a paired or not. The first condition is n1 is my 12, n2 is my 12. So it could be, it may or may not be the paired. Okay, so how do you identify that? If you read this statement carefully, an automotive engineer is investigating 2 different types of devices for an fuel injections and determine whether they have the same mileage or not. So nothing is given to you, so it means this is talking about the information. Look about the next line. The system is installed on the 12 different cars and the test is run with each metering device on the each car. Look at these 2 words, each meter, each car. What is the meaning of this? This 17.6 is the is the reading of the car 1, and 16.8 is also the metering of the car 1. Are both the cars same? Are both the cars same? So that is assured by this line. Each metering on the each car, it means both the cars are same. So once it means this 17.6 and 16.8 is depend on what? Depend on the car 1. So once it's a dependent, so we call this as the paired test. Fine. This is the way you can check whether it's a paired or not. Read the statement carefully. Then your target is to define the H0, H1. Look at the last line, because your target is to check this one, whether the median. So if I call this is my eta 1 for the mileage 1, eta 2 for here, check whether the is same or not. It means this is your target. Fine. So since it is a equality, so once it's a equality, it is always in the form of the H0. So what is the opposite of this? This is the opposite. So this is my H0 and H1. Remember, if it is called as, say, fuel mileage of first is superior to the second, what is the meaning of that? They are talking about that eta 1 is greater than of the eta 2. This is the question. So is the equality appears? No, because superior doesn't imply the equality. So since equality does not appear, so this is my H1. What is the opposite of this? The opposite of this is my less than or equal to. Then in that case it will be here. But anyhow, in this example, this is my here. Now we will look at the second step. We will compute the T positive and the T negative. We will take, this is my X, this is my Y. We compute X minus Y, or you compute Y minus X. That's depending upon you. So let's find the X minus Y and simply sign the sign. The first number is positive, second number is negative, third is positive, and so on. You will compute here. Now compute the number of the positive sign. How many positive signs are there? 1, 2, 3, 4, 5, 6, 7, 8. This is my 8. Number of the negative signs are my 4. What is the n is? Total is my here, and the minimum is my 4. Now look at that. This n is my 12, which is greater than or equal to 10. So this is the part of the large sample. So anyhow, right now we are talking about the small sample. So for the demonstration purpose, I explain this with the help of the small sample. I will consider same example in our after that 2 or 3 minutes we will describe the large sample as well in the same video. So since n is my 12, it's a large sample, but I explained, as I told, I consider as a small sample for the demonstration. Look at this. It's a two-tail. Level of significance is 5%. So look at that. The value is my 2. So the critical value is my 2. Therefore, what is my critical reason? Critical reason is less than equal to that number. So this is my. Now you have to check whether this condition satisfied or not. Clearly says that 4 is greater than equal to 2. So it means we will fail to reject it H0. If it satisfied them, then we rejected H0. Otherwise we may accept it H0. It means this is accepted. What is the meaning of the equality? Hence we may conclude there is no difference between their medians. That is, the device provides the same median fuel mileage performance. Look at the next example. So again you have to use the sign test. N1 and N2 both are same, but whether it's a paired or not, we will look about this statement. 2 different types of the tips are used for the rope well. 8 coupons are selected. Each coupon is tested twice, one with each tip. So what is the meaning of that? Each coupon is tested on the each tip. You can see each coupon is tested on the each tip. So what is the meaning of that? This 63 is dependent on the coupon 1. Is this 60 is dependent on the same coupon? Yes. So it means, what is the meaning of that? Both are dependent on this coupon 1. Similarly, these are dependent on the coupon 2 and so on. Hence, it is a paired sign test. Now, once you identify it's a paired sign, then you have to check what is H0 and H1. Determine whether or not the two samples produce equivalent hardness or not. These are equivalent and these are not equivalent. So clearly say that this is the equality. We consider this as H0 and this is my H1. Now we will look about the signs. So it is a positive sign, it is a negative positive sign, it is a positive sign, it's a positive sign, this is a negative sign, and so on. Based on this you can compute the T positive, which is a 6, T negative is my 2. You can compute the N, you can compute the capital T. Look at that, the N is my less than 10, so it is a small sample. So we will look about the table corresponding to N is equal to 8, 2 tail, level of significance is 5%, value is 0. So the critical region is my less than 0. Check whether 2 is satisfied here. It is not satisfied, so we fail to reject it H0, or we may accept it H0. Once it is accepted, it means there is equivalence hardness reading between them. Look at the another one. Again you can see each using the two different kinds. That's again the pair test. You have to check whether the medians are significant difference or not. So they are not talking about the anything, so it means this is my condition corresponding to this. So it is the case of the H1 because equality does not appear. Now we can compute the difference. You can compute the sign. Clearly say that the second number is my 0, this number is my positive, this number is my positive, this is my positive, this is 0, this is negative, and so on. Now ignore these 0 signs. Ignoring the 0 signs, compute the T positive, T negative, compute the values of the N. Again N is my less than 10, so it's a small sample. Look at the degree, look at the critical value. Again 2 doesn't false that, so it means there is fail to rejected H0. That means H0 is accepted H0. That means there is no difference between them. Now look at the large sample. So large sample is only when the value of this N is my greater than of the 10. So as we described that for the sign test, the probability is half. Let small p is the probability of the T positive sign. That's a T positive. So since p is my 0.5, so it means that this x follows the binomial distribution with the probability of here. Also we know that for the binomial distribution, whenever p is my half, what is the meaning of that? It tends to the normal distribution. Why? Because the probability is half, means that's a symmetric distribution. So whenever p is half, the binomial distribution is approximated by normal distribution. What is the mean of the binomial distribution? NP. Variance is here. So this is my here. What is the mean of this x? N by 2. What is the variance of this x is? NPQ. NPQ. That is a n by 4. So that is a variance. That is a T positive. That is a probability of the positive sign follows the normal distribution. Once is follow the normal distribution, remember n must be greater than of the 10. Then we can apply this. We will check whether the T positive is greater than of the n by 2 or less than, and then we can define this standard normal variable. You can see what is the mean, what is the T positive is a normal distribution with the mean is n by 2, n by 4. So since it is a discrete, so we have to apply the approximation as 0.5 minus what is the mean is n by 2, what is the variance is n by 4. So this n by 4 I can written like of this. Similarly this plus 5 and the minus 5 is based on the continuity correction from discrete to continuous. Now the procedure is again similar. We will compute the H0 and H1. We will compute the value of the n. Then based on this value of the Tn and the n, we can compute these two values. So because it's a normal distribution, we can go here. This is my critical value. This is the critical value we can compute from the Z table at 5% or the 1%. Remember that for the 5% its value is 1.96 and 1.465 for the one tail and for the two tail, and same value for the 2.33 and 2.58 for the 1% level of significance. You can remember that. And once you can find this is a critical value, check whatever the value you have obtained from here, it lies in this portion or in this portion. If it lies in this portion, we can accept it, otherwise reject it. Look at that. This is the same example I described in the previous one. Although it's a small sample, but in this question they are asking that use the normal approximation. That means they are talking about the large sample. Do the similar manner, we compute the step 1, we compute the value of the n here, although it's a small sample, but the question asks about this large sample and the level of significance is 5. Now we will check what is the t positive is 6, what is the n over 2, n is my 8, so it is by 4, clearly says that t positive is my here. Once is a greater than, we can compute the value of this. What is the t positive 6? This is my 0.5 minus 4 divided by half of root 8. So it is my 1.5 divided by half of root 8. So after the calculation you will get this as the answer. Now what is the level of significance is 5%. The critical value at 2 tail is by 1.96. Look at that, the value of this lies where? It lies at somewhere here. That means it lies in the accepted H0. So we can say since 1.06 lies in the accepted portion, so we fail to rejected H0, or you can say we may accepted H0. Hence there is no, because H0 is accepted, so this is accepted, so there is no significant difference between the median of the measure. Look at the another one. So if you read this statement, clearly says that this 1.6 is dependent on the panel 1. 1.8 is also dependent on this panel 1, that is for the same panel. Hence it is a paired sign test, because you have to apply the sign test. Now is there any evidence that the median dying are different? Median dying are different means you have to check about this one, because again they are not talking about that which one is a superior. So this is my H1 because equality does not appear. So we can here. Now compute the signs. You can see the first sign is my negative, second sign is negative, third sign is 0, fourth sign is negative, fifth sign is positive, and so on. After computing you will get these signs are. Ignore these zeros, compute the t positive, compute the t negative, and the value of the n as here. Clearly says that n is my 18, which is a greater than or equal to 10, so it is my large sample. Once is a large sample, you have to check what is the t positive. This is my 3. What is the n over 2? N is my 18, so it's a 9. Clearly says that this time is my less than of n by 2. So once is a less than of this, we can apply sign of this. We can substitute this value. This is my here, n by 2 is my 9. This is half, n is my 18. So clearly say that this number becomes my minus of this. Now if you read this statement, what is the level of significance is? Level of significance is given to you as a 1%. What is the critical value of the 2 tail is 2.58. So we can start from here 2.5. So look at that, minus 3.66 is lies here, which lies in the rejected H0. It means this is my rejected and H1 is my accepted. And since H1 is not equal to, it means both the medians are not same. It means there is a significant difference between the median dying times of the two formulas. This is the way you can apply for the paired sample t-test for the small sample and the large sample. We will see the next lecture on the Wilcoxon sign rank test. I hope you can simply learn this concept. You can like, share and comment my these videos with your friends. Best of luck students. Happy learning.